When we talked about how to write shell scripts in a previous video, we talked about two jump statements. One is called the break, and the other one is called continue. Those two jump statements allow us to alter the execution of loops. In C++, we also have these two jump statements, and they are also called break and continue, and their meaning is exactly the same as what we have talked about in writing shell script. So the break statement is going to break the entire loop and bring the execution to the end of the loop. And the continue is going to break the current iteration and then continue to the beginning of the next iteration of the same loop. So that's sort of two different ways for you to alter the flow of a loop. So suppose I add a break statement in the else branch of this if construct. So what's going to happen if I put a break statement here? So when IP, the loop index is smaller than ap.size, so the ap.size at the beginning ap.size is going to be 30 because the AP was sort of initialized to have 30 elements in it. So when the loop counter is smaller than 30, it's gonna sort of just alter the content of the content of the current AP vector by executing this loop, this body of the branch. But as soon as AP actually reached the size of AP, the existing size of AP, that's 30. As soon as AP actually equals to 30, then it's gonna come to this. It's gonna come to this line. It's called break. And then break is gonna take the execution to the end of the loop. The end of the loop is here. And then it's gonna continue executing to this line. You're gonna close the input file. So if you actually put a break here, it's not gonna execute this. This line. It's just gonna close the file and end the entire loop. So the AP, the size of the AP is gonna stay at 30. And let's see if that's true. Let's just compile it and then run it. So you can sort of see the size of the AP vector is still 30. So this is actually the printout from here. And then the name of the first person is still the same, but the name of the last person, the end, is different from the previous run. And it should be the name of the 30th patient in the text file. Suppose this is a text file that we are looking at. Suppose I go to line 30. The name is exactly the same as the 30th patient inside of the text file. So that's break. You can use the break to end or terminate the loop in the middle of the loop. It doesn't have to sort of continue executing forever. Continue executing to the condition becomes false. So that's break. Now let's look at how we can actually use the continue statement. Suppose we would like to skip a line in the text input file. We would like to, for example, skip the 10th patient inside of my text file. So how we can actually use that? How we can use continue to achieve that kind of purpose, right? So if IP, here I'm doing a comparison with the number 9 because it's 0 based. So the 10th record is actually the corresponding to the loop iterator that's equals to 9. So here's this if statement. So you have to pay attention to this comparison symbol. If you want to sort of compare a number with another number and see if they are equal to each other, you have to use the equal to sign. So if you forget about one of the equal signs, then this statement becomes an assignment statement. Basically, you're assigning the number 9 back to the variable IP, and IP is the unsigned int. So this assignment will succeed, and it's gonna return a true. So if you do that, this if statement is always gonna execute because this statement is gonna return a true. If you really want to do a comparison, don't forget about to use 2 equal sign. That's a comparison to test if IP indeed has a value of 9, has a value that's equal to 9. So it might be tempting to just write continue here. But is that going to work? Is that going to achieve our purpose to skip just one line? Is that going to work? It's not going to work, actually. It's not going to work. But let's try to understand why. Let's try to understand why it's not going to work. So IP started from 0. So 0 not equal to 9. So it's not gonna execute this continue line. It's gonna skip this if, and then keep executing the rest of the lines inside of this loop. So it's gonna read the text file and then archive the content or the information back to this vector of AP. And then after it has done that, it's gonna increase IP by 1. So IP is gonna come to the number 1. And then for the next iteration, it's still gonna skip this if, and then keep executing, and then increase IP. This time IP has a value of 2. So it's going to keep executing until what? Until IP equals to 9. And when IP equals to 9, this line becomes true. So it's going to execute this continue. This continue is going to do what? It's going to take the flow back to the beginning of the next iteration. So it's going to skip all the lines that's underneath it and go back to the beginning of the next iteration, which is get line. So it's going to get to the next line. It's going to get to the next line without increasing IP. So IP, because the line for increasing IP is way at the bottom of this loop. So it's not going to increase IP. IP is still going to have a value of 9. So for the next iteration, IP is still going to have a value of 9. This comparison is still going to be true, and it's going to execute this continue. If it executes this continue, it's going to skip all the lines below. It's still going to skip this particular line. And IP is still going to have a value of 9. It's going to have a value of 9 for the rest of the loop until this condition becomes false. So that's not exactly what we wanted. What we wanted is to just skip the 10th record. So before we actually continue, we have to remember to increase IP. Actually, we have to do an IP to plus IP to increase the IP by just the number, but by increase the IP by 1. So this way, when IP equals to 9, you increase it by 1. So IP actually becomes 10. Now you continue. You skip all the rest of the lines, including this incremental line, this plus IP line. And then you go back to the beginning of the next iteration, get line. But now IP actually has a value of 10 now. So for the next iteration, for IP equals to 10, this if is going to be skipped, and it's going to keep executing the rest of the lines. So how do I actually make sure that the 9th record in the file is indeed skipped? So let's print out the name of the 9th record. Let's print out the name of the 9th record. Because the AP was initialized to have a name of Kevin for all the first 30 elements. Actually, if you don't exactly remember, it's the line for initializing the vector AP was here. It was initialized to have 30 elements, and every element is going to have this kind of information. It's going to be initialized to have a name of Kevin. But for the text file that we are actually reading, you must have like first name and second name. It's not just Kevin. So if the 9th record is still Kevin, which means that I have successfully skipped the 10th record in the text file. And let's see if that's true. Let's save it, build it, and then let's just run it. And then you can sort of see that's the 9th record, the last printout. The 9th record indeed has the name of Kevin. In practice, the text file may not have the kind of a format that we were actually using. So if you actually remember, the text file that we had was delimited by spaces. So we were able to actually read the entire file one line at a time, and then we use a line to construct a called a string stream object, and then we can read from this string stream object str and read the content into first, last, sex, age, and those three vital signs. But we have to remember that the line, the different columns in the line were delimited or separated using space. So this syntax actually works. So we can use this syntax to get the information from the string stream, input string stream, to all those different variables. But if in practice your text file may not have this kind of a regular format, it may use different kinds of delimiters on different lines, for example. Right? So one possibility is like this kind of situation. So that's the name, and then comma. You are using a comma to separate the name from the sex, and then using comma to separate the sex from the age, and then use another comma to separate the age from the three vital signs. The three vital signs are separated using space. So in this, for the first line, you actually have two types of delimiters: the space and also the comma. The space as a delimiter here, but the comma space as a delimiter here. And then once you go to the second line, again all the words are separated using space again. So comma is not a delimiter for the second line anymore. So if you have this kind of situation, it will introduce some complexity to the procedure for reading the file into the correct format for reading the file. So now let's try to sort of change our code to accommodate this kind of situation. Is it possible for us to change it in a way that it can read those files that's not exactly separated using space, using those different files whose columns are not exactly separated using space? So we need to account for other kinds of delimiter in practice. We need to account for those situations. So how are we going to do that, right? How are we going to do that? So if we are not going to using a iString stream, let's comment out this line. So we're going to comment out this line, and then we're going to comment out this line, because we cannot use this line to read the text file that's not delimited by space anymore. So, but now let's try to sort of add some new codes that can handle more complicated situation. So the function that I'm going to use to split up the line based on a certain set of delimiters is called strtok. It's a C function, but as what I was telling you, C++ can use C. So any C function can be used in C++ codes also. It is a function that allows you to tokenize a line based on a set of a string or character string based on a given set of delimiters. So basically, this function allows you to do strtok. It takes some inputs. Basically, you can just give it like two inputs: a character string and then a set of delimiters. So the delimiters has to be included in the double quotation signs. So the delimiter that we're going to use is the space. Space is definitely one of the delimiters, and then we're going to use dot the comma. And then if you also want to use the dot as one of the delimiters, you can also add the dot or any other kind of symbols. For example, sometimes people use this kind of thing, using a dash, for example, or slash, that kind of thing. So here we'll just you can put those things in there. It's not going to change the. It's not going to change. It's going to. There's no harm to adding more delimiters to it. But for this particular example, let's just put comma and dot. So strtok is going to take some kind of character string and then a specification of delimiters. And then what it's gonna return? It's gonna return another character string. Let's just call it a character string. Let's just call it PCH. We'll look at what's actually the type of PCH a little bit later, but that's sort of the basic usage of strtok, the tokenizing command or tokenizing function for comes from the C language. So, but now let's try to make sure that this is a correct call to strtok. If you actually sort of search for strtok, so here if I just hover my cursor on top of the function name, you can sort of see it's telling me I have an invalid argument. It's telling me I have a bug here. The reason that the bug is that it actually requires a char star and then const char star as two inputs. But what I'm actually feeding into the first input is a line. Line is what? If you look at the definition for line, it's a string. A string is certainly a different type from a char star. So now let's try to talk about a char star. Because the char star is also the return type of strtok. You can sort of see that's the return type char star. So what I can do is to define a char star for PCH. Then it's gonna then PCH will have the right type. It's gonna be a char star. So in C language, star is actually used to define a pointer. And a char star is just a pointer that points to a sequence of characters. So the pointer is actually a quite useful construct. It is somehow like an alias, but it's still different. But you can use it in certain ways that allows you to sort of make changes to the stuff that it's pointing to. So a pointer is basically some kind of handle that points to or references to another thing. So PCH is a pointer that points to a sequence of characters. So basically you can use the PCH of pointer to the CHR to access all the characters that's inside of the string by using the pointer. So in a previous video I talked about the iterator. So iterator is some kind of generalization of a pointer. So it allows you to actually it is some kind of glorified pointer. And a pointer is basically sort of you can use it just like using an iterator. That kind of thing. So we're going to look at how we can actually use char star. This space is actually unnecessary. I can just declare char star PCH, then I can use this thing. But the thing is that it also requires an input that's to be char star. The line is a string. A string is a C++ object. But the good thing about a string is that it provides member functions because it's an object. So you have functions that you can call. So suppose I type a dot, and then I'm just gonna wait. I'm just gonna wait for the IDE to give me this pull down menu. So I can select from this pull down menu a particular function that I can call for the string object line. The function that I'm gonna use is called cstr. You can sort of see it's a returning. So cstr is a member function of the string object. It takes no input because the input is void, and then it returns a const char star. So the return type is a const char star. It's not exactly a char star, but it's a const char star. Let me just double click on it. So I'm calling this particular function. particular function. So it's gonna return a const char star. In fact, this is actually doing a type conversion. It's converting from a C++ string object and to a char star. That's kind of a C type. C type. But the problem is that it's a const char star. It's not a char star. And strtok is actually requesting a const char star. So there's still a bug here. There's still a bug here because it's asking for a CHR star, not const CHR. Const means what? If you define a const CHR star, say PCH or something, the const keyword actually means that the stuff that's defined here cannot be changed. So the variable, if you remove the const, it's gonna be a CHR star, and then the CHR star itself can be modified. For example, I can actually sort of put this pointer and sort of for example increase it by 1. For iterator, if you increase it by 1, it means what? It moves to the next element in the container. But for a pointer, if you actually for ordinary pointer, not the iterator, if you actually increase it by 1, it means that it's going to move to the next element inside of the array that it's pointing to. So in this case, it's going to shift its position to the stuff that's pointing to the next character inside of the character string. So that's what this actually means. So if you do a const CHR star, it means that the PPCH itself cannot be changed. But that's not what strtok is requesting. So what we have to do is to change its constness of the return type. And C++ actually provides you a mechanism for doing that. It's called a const cast. And then I have to use a parenthesis to enclose this part of the code. So const CHR star, const cast actually casts away the constness of the return type of line.c_str. So that's the purpose of the const cast. It allows you to cast away the constness of the return type for line.c_str. And then what's going to be the pointer that you are casting? It's going to be a CHR star. So by prefixing this particular statement in front of this return type, it's going to make the return type correct. So now we have a PCH. So PCH is what? PCH is going to be, so here we are actually feeding strtok a sequence of characters, and then strtok is going to pass this sequence of characters and look for any of the characters that's sort of enclosed in here, the delimiters, either a space or a comma or a dot. Once it finds the first occurrence of any one of those delimiters, it's going to split the string, and then take the front part of the string and put it into PCH. So the PCH is going to be the first occurrence. It's going to be the text in front of the first occurrence of any of those delimiters. But that's not the whole story, because our line has multiple fields or multiple columns. We have to sort of keep parsing. We have to keep parsing the rest of the text. And what's actually the syntax for parsing the rest of the text inside of the line, right? Here again, we can use a while. And the condition for stopping the loop looks like this: PCH not equal to now. So now is a particular name for indicating the end of the string, actually. The end of the string. So C strings or C character arrays are always ended with a now. So C, here we are actually sort of using a line.cstr to return, to convert a string type to a CHR star type. It's a character pointer. And the end of the line, end of this particular C string is going to be marked with a now. So basically we are actually effectively sort of comparing PCH with the end of the string. So as long as PCH is not equal to the now, the end of the string, I have to keep parsing. So the stuff that how do we actually keep parsing? again we call strtok. strtok takes two types of parameters. So in this particular call, what we are feeding to it in the first argument is a CHAR star, basically a CHAR star. Here we are actually feeding it a now, the end of the string. So strtok actually has the intelligence to know the difference, So if you are actually feeding strtok with the end of the string, it's gonna keep pass whatever is left from the last pass. So if you are feeding it a now, then it's gonna keep passing the leftover from this pass. The leftover from this pass is actually the end of the first encounters of any of the occurrence of the delimiter. That's the rest of the string. So if you want to sort of look at what's actually the content of PCH, you can feed it into cout, and then let's take a look at what's going to happen. So we're just going to pass the first line. Let's just break here, because I don't want to sort of look at the rest of all the lines. I just want to look at the information from the first line. So I forgot to comment out these lines because I have defined the vitals here, but I have repeated the definition of the same variable twice. So I have to comment out these lines also. Now let's try to sort of run it. Let's try to compile it and make sure that there's no error. And then let's try to run it. So the printout happens here. That's the first line. This line is actually coming from the printout here. That's the cout. And then I am doing the parsing. I'm actually doing the tokenization of this particular line. And the delimiter I gave was space, comma, and dot. So the result of the PCH, the while loop, is that here I have a cout in the while loop. So the PCH actually changed from the first one, and then the second one, the third one. And the first PCH actually is coming from this call to strtok. That's the first output here. So this MEDI actually coming from this particular call to strtok, and then WIER, and then the rest of them are coming from this call. So basically I can actually tokenize the string based on whatever delimiter I use. Now, since I can actually pass a line based on whatever delimiter, or tokenize the line based on whatever delimiter, I can put the tokenized character CHAR stars into, for example, a vector. So here I'm actually defining a vector of character pointers. So I'll just call it a VPCH, a vector of PCH. And then here I can do a pushback, VPCH dot pushback PCH. So every time I get a new PCH, I can sort of put it back to put it into this VPCH container. And this way, I can sort of keep a record of all the PCH that I have come up with through this tokenizing process. And now let's try to convert the stuff that's in the vector CHAR star VPCH into the correct format. So what we are going to need is a string of first, string of last, and then a string sex, and then an integer age, and then the three vitals that are float. So how are we going to do the the type conversion, right? So first is going to be the first name. It's supposed to be a string, but we can actually do this. We can do VPCH 0. So VPCH is going to store a character star that's pointing to the first name. Here, by doing this kind of assignment, I'm actually assigning a CHAR star to a string. A string object actually includes, the string object actually has a what they call the assignment operator, and this assignment operator can actually account for this kind of type conversion automatically. So this assignment will actually automatically convert a char star to a string. And then the same thing for the last name. And then the same thing for sex. So that's the first name, last name, and then sex. And then the next one is supposed to be age. Age is an integer. But how do you actually convert a char star to an integer? There is a function, again, a C function. It's called a to I. This a to I C function allows you to convert char star to an integer, age. So if you actually move your cursor to a to I, the IDE is actually going to print out how to call the a to I. It's going to ask for a constant char star, and then it's going to return a int. And then the three vitals, these are float. And you can imagine there must be a function, C function, that's called a to f, that allows you to convert char star to floating point numbers. So that's the three vitals. And that's pretty much it. So we have actually tokenized this particular line, each line. And the tokens are stored in char stars. And those char stars are kind of archived in a vector that's called a vpch. And this tokenizing process is carried out using strtok and also a while loop. And then we did some type conversions. Char star to string is carried out by using this assignment operator. That's kind of defined as some kind of member function of the string object. First, last, and sex are all string objects, so you can call this assignment operator on it. And then age and vitals are integers and floating point numbers. So you have to call the C function a to I to convert to integer, to convert the character to char star to integer, and then a to f convert char star to floating point numbers. And then the rest of the codes are still the same. You don't really have to change the rest of the codes. So here you're actually putting the here you're actually putting the information into the existing AP vector. That's a vector of persons. And here you are doing pushbacks, and then increasing the loop count by 1. So let's save it and compile it, and then let's see what's going to happen. Right. So it's going to in the end of this, it's going to print out several things. One is the size of the area of persons or vector of persons. That's going to be 50. The name of the first person in that text file, and then the name of the last person in that text file, and then the name of the 9th person in that text file, and then the full information for the first and the second person in that particular file. And it all looks correct, actually. An even more complicated situation is something that looks like this. So the record for each patient is separated into multiple lines. In this particular case, the record for every patient is separated into 3 lines. The first line is the name, first and last name. The second line is for sex and age, and then the third line is for the 3 vitals. So, and each of the line actually has different delimiters. The first line is separated by, the words are separated by a space, but for the second line it's a comma space, and then the third line is a space again. So this kind of thing will make it harder to to read into C++. And this file is called person3 on .txt on my system. So let's try to modify our code to account for this kind of a multi-line per record situation. In this case, it's just the 3-line per record situation. So let's still try to sort of modify our codes to account for this kind of situation. And we're gonna keep the basic structure. Of course, the file name has to be changed. The input file name has to be changed to this new file name, person3.txt. I'm still gonna sort of keep the basic structure of the loop. I'm still gonna use a while loop, but this time, for the first iteration, when you run this while loop, it's gonna get the line that contains the name of the first patient. It's just gonna be the name. There's no age, sex, and vital information for that particular person. Just because the first line is just as a name actually. So it's gonna return the name. So I'm gonna define a string, first, last, sex, and then int age, and then vector, a 3 vector for floats initialized to 0. So I'm still gonna use the strtok to tokenize each line that I read, and this time I'm gonna put I'm gonna put every token that I passed from this line into a vector of string instead of a vector of char star. I'm going to use a vector of string, and then each token is still represented as a char star. So pch equals to strtok, and then do this const cast chr star to line.cstr underscore line.c underscore str is going to convert it into a character array, and then cast away the constantness, and then it's going to be passed or tokenized using space, comma, and dot, these 3 types of delimiters. Of course, for the first line, pch is just going to be the first name, and then if I do this while loop, pch is going to get the second name, the last name. I mean, the last name, and then I'm doing this pch dot pushback, but I'm pushing back what? Pushing back is a string actually. This is actually initializing a string object, and then push back that string into vpch, because the vpch now has been changed to what? Vpch now has been changed to a vector of string here. So I need to push back a string. So here I construct a string on the fly, and then initialize it using pch, the chr star that I just sort of passed from the from the line. So as soon as I finish passing the first line, I'm gonna assign vpch0 to the first name, and then vpch1 to last. That's the last name. But that's not enough. This is just the name information. I still need to do another get line. I need to get another line, still from the person file, into line, and then now I have to do another tokenization. chr star, and then line.cstr space, comma, dot, and then that's it, and then do the while loop. So this is actually getting the line that contains the sex and the age information. So I'm gonna do vpch.pushback construct a string pch, and then pch equals to strtok null space dot. So this is to account for the second line in the same record. That contains this line contains the sex and the age information. So as soon as I'm done parsing it, I'll assign my variables, because sex information is still a string, so all I have to do is to get access to the second to VPCH2 to assignment, and then that's a string assigning back to a string, so that's completely fine. But age is an integer, so I have to do a conversion. So this A to I can still use A to I, but this time it's going to require A to I is going to require a CHR star as an input. So what I have to do is to VPCH3. VPCH3 is a string, so I have to cast it into a CHR star, and I can do that by calling the CSTR function. So this way I can get the age, the integer for age. So that's the second line of the record. Let me just make a comment. First line of record, which is name, first and last name. So this is the second line of record. That's sex and age. Now I'm doing the third line of record, which is vitals, which are the three vitals. Again, I can just copy and paste all these lines here. Control C, Control V, and then all I have to do is to assign the vitals. But now I have to call A to F. Again, I have to convert, because VPCH4 now is a string, I have to convert it into a CHR star. So basically that's it. So here I'm actually reading the first line, which contains just the first name and last name. For the first line you don't really see the get line. You don't see the get line here, because the get line actually happens in the while loop when you try to actually determine if you have reached the end of the line yet. But for the second line of the same record, you have to explicitly call get line and then tokenize it. And then for the third line of the same record, you have to explicitly call get line and then tokenize it. So after you're done, you have to sort of put the information back into the put into AP, put into the vector of presence. Put that information, store the information back into the vector AP. And then the rest of the codes are still the same. So I'm not actually changing this part of the codes. So, and then for the next iteration of the same loop, it's gonna go back. It's gonna go back to the beginning of the loop and then do the get line again. So if the file has not finished yet, if you have not reached the end of the file yet, you're gonna retrieve the name of the second record, the second patient in the text file. So now let's save it and build it, and then let's just run it. And the result is still correct. 50 records, names, and then the complete information for the first and the second patient, which is printed out from here, which is still correct. C++ is an object-oriented programming language. So object-oriented programming is one of its strengths, and we should talk about how to write object-oriented codes. In my previous example, I was showing you this particular class. It's called a person. Basically, it defines a name, which is a string, and then an age, it's an integer, and then a gender, that's another string, and then 3 floating point numbers, which is sort of encapsulated in this vector floats that's called vitals, which is basically your heart rate and the two blood pressure measurements. So in my previous example, I was basically using this particular class as some kind of a data type. So it's basically just a composite data type that contains some 1, 2, 3, 4 smaller data types. Two of them are string, one of them is an integer, and then one of them is a vector float. So basically I was using the class as merely a container, as just a container for storing for storing those smaller containers basically. But the capability of a class is far beyond just being a container. So you can actually do a lot of things without with the class actually. So the basic unit for writing a object-oriented programming code is basically just the class. And the class, you can define multiple classes. The classes can interact with each other, and those classes can inherit from each other, and you can come up with composite classes. So those interactions among classes actually makes object-oriented programming so much interesting, so much sort of makes the language so expressive, and makes it so a lot of fun to actually write C++ programs. So let's look at how we can actually make our example sort of more interesting. For now, I'm just using here I have defined the class. So a class has to start with the keyword class, and then followed by the name of the class, and then the body of the class has to be enclosed in a pair of curly brackets, and then you end the so this is sort of the declaration of the class, and then you can sort of end it with a semicolon, and then you just define all your variables inside of it. So that's the definition of the class. And then how can we actually use it, right? Here I have defined a person. So you can sort of you can define a person object. Here I'm actually using the name P. So P is an instantiation of the person class, and it's called an object. It's an object of person. So, and then you can initialize it. You can initialize it using the universal initialization which is basically just the curly brackets, and then put all the values for the initial for the public data members inside these curly brackets. So basically, this initialization actually has it's actually two initializations. One is of course for the person object P, which is the outside pair of curly brackets, and you assign Bob to the name string, to the string name, and then 30 to the age, and then sex, male to the sex, string sex, and then the vector float, this vector of floats assigned to this vector floats, to the vitals. But there's also a inner initialization, which is the initialization of the vector floats. You're basically initializing a vector floats with three numbers in it, so 75, 120, 90. This is also a pair of curly brackets, and this is for initialization of a vector floats. And this vector floats doesn't really have a name in it, but it's sort of constructed on the fly and then passed to the vector float in the vitals right away actually. So that's one of the ways for us to use a class, basically using it as a data container, and you can initialize it. So but what I can say about this particular class is that it's actually not a very good design in terms of the class layout. Usually, many years of software engineering experience has taught people that it's actually a poor practice to expose the data members of a class as public. A far better design is to hide those data members as private, and then use public functions. Those are functions that are written by the class author to control the access to those private data members. So writing a class like this is not a very good practice. So a better practice is to keep the data members as private, and then write access codes to control the access or read write to those variables. And inside of those access codes, the author of the class can build in all sorts of checks. You can sort of check to make sure that the user of the class is indeed giving sensible sort of numbers or sensible information to the data members of the class, that kind of thing. And you can also do lots of other sort of things inside of your access codes. But before we do that, before we sort of write access codes, let's talk about constructors and destructors. One very important principle about C++ is that every object inside of C++ has to be initialized. And constructors and destructors handles the initialization of the object, and also the destructor of the class actually handles how you can actually safely destroy the object. So constructors and destructors are two very special, very important member functions of any class. So if we actually look at this particular class, we don't see a constructor. We don't see a particular function at all. We don't really see any function. The reason is that, but this class also still has a constructor. It's called a default constructor, and it's synthesized by C++ language itself. So if you don't define any constructor for a particular class, C++ is going to define a default constructor for you, and it's going to call that default constructor every time you try to sort of instantiate a certain class, the person class, for example, P. So every time you define an object of person, the default constructor gets called because you didn't define a constructor by yourself, right? But it's not a good idea to rely on the system synthesized constructor. A good practice is to always write your own constructor. You write your own constructor and your own destructor. So how are we going to write a constructor, right? So first let's change the access level of our data members from public to private. In fact, all the data members are default if you do not specify any sort of access level. If you just remove private, the default access level for anything that's kind of in here is actually private. So you don't really have to sort of specify private access level. So default access level is private. But just to make it sort of more obvious, let's still write the private access level here. And then we're going to define our public members. And the first public member that we're going to introduce is the constructor. So what I was telling you is that the constructor is just a function. It's just a function. So how do you actually define a function? You define a function by some kind of return type, and then the name, and then a parenthesis for you to give the input, right? For a constructor, the name of the constructor is kind of special. The name of the constructor is exactly the same as the name of the class, actually. So if you define a function that's called a person, and then this person function is going to be the constructor of this particular class, because the class is also named person. So a constructor must have the same name as the name of the class. So here I'm actually sort of saying that I'm actually defining a constructor. So what's gonna be the input to this particular function, to this particular constructor function, right? We're gonna give it a string. Let's just call it NAM. And then a int, let's just call it AG. And then a string again, let's just call it SE. And then a vector floats. And this time let's call it VI. And then basically that's a constructor. You have declared a constructor. This is a declaration. It doesn't have the body of the function yet. So if you want to just do a declaration, you end this line with a semicolon instead of curly brackets. If you are making a definition of a function, you should just write like that. But here you are actually doing a declaration. So here we end it with a semicolon, so it's a declaration. The constructor doesn't return anything. It doesn't even return void. If you are a C programmer, you probably know about void. This particular If you don't want to return anything, you can return a void. But for a constructor, it doesn't even return a void. It doesn't return anything. So that's sort of how you can actually sort of declare a constructor. And now let's try to sort of let's try to define. Let's try to define this constructor function. How do you actually define the constructor function? You write it like that. Because the person, the constructor function, is a member of the person class. So what you have to do is to use the double semicolon. You use double semicolon, the scoping operator, to access a member inside of this person class. So I'm actually defining the constructor. So I have to sort of but this time it's a definition, so I have to give it a so here I'm actually defining, trying to define the body of the constructor function, and so here what I'm supposed to do with this particular initialization list? No, this input parameters, right? So I'm actually supposed to actually assign them back to those data members, those private data members. So since those private data, those data members are private to this particular class, so users of this class don't really have direct access to those private data members. So they have to sort of rely on member functions to actually get access to those data members. So when you initialize or define an object of a person, for example here, you're trying to sort of assign some initialization values to those data members, and you do that inside of this constructor. Because the constructor is a member of this particular class, so this member actually has access to its private data members. So now I can access name, for example. I can use name equals to name, and then age. This name is actually this name. It's actually this data member, so I don't have to declare it anything because it's already declared here. Age equals to ag, and then sex equals to se, and then vi, vitals equals to vi, and then that's pretty much everything that I want to do in the constructor. All I have to do is to initialize it. Initialize all the private data members. That's the primary functionality. That's the primary duty of a constructor, basically. So now let's just save it, and then let's just build it. It has passed the compiler, so it looks like it doesn't have any error. But let's try to define another public function. We're going to define another public function so that we can take a look at the value of those private data members. So we're going to define another function that's called print, and this print doesn't take any inputs, and it doesn't really return anything. But this time it's going to be a void, so it's going to return a void because this is the ordinary member function. It's not a constructor anymore, so you have to give it a return type. Let's just give it a void. We don't really return anything. And the print function is going to print out the values, the current values of those private data members. So we're going to sort of write a print member function that's called print. So again, we have to sort of define the body of print here because it's a void, so I have to sort of give a return type, and then it doesn't really have any sort of input, so I can just leave the parentheses empty. So now I can sort of see out. So name again, it's because it's a member of this particular class, so this particular member function has access to its private data members. So the name that I'm using here, printing here, is actually the name that's stored in the private data member. So I don't really have to declare the name or define the name anymore. It's just the same name here. And then cout gender. And then age. So I'm going to print out the gender and the age on the same line. And then cout name, gender, age, and then the vitals. Vitals basically so basically that's the kind of information I want to print out if I call the print member function. So here I have defined a person object P, so I can actually, and I have initialized it with some kind of a sort of information, and then I can just call the member function print. So if I type P dot, then it's going to give me a drop-down menu. The IDE is going to give me a drop-down menu. So now the data members are kind of a private, so it's not, you have this kind of symbol in front of those private data members, right? But this print is actually a public data member, a public function member, so you can actually call print, right? And then let's see what's going to happen. Let's just see what's going to happen. Let's build it first, and then just run it. So now it's actually printing out Bob, gender male, age 30, and then vitals is like this set of vitals. Maybe it's not a good idea to put this on the same line, so I'm gonna give it another ENDL. Maybe this time it's gonna look slightly better. So. Right, name Bob, gender male, and then age 30, and the vitals. The vitals are actually floating point numbers. Maybe I should specify what's gonna be the precision, for example. I'm gonna use a fixed precision, right? And then set precision. I'm just gonna give it 1. So I want to just one number after the floating point number. No, I have to save it first. Now it looks like it's actually treating the numbers as floating point numbers with 1 digits after the floating point actually. So we have defined 2 member functions. One is a public. Both of them are public. One is a constructor, and this particular constructor takes a sequence of input variables, and then it's just gonna assign those input variables to the private data members, to the corresponding data members. That's it. So that's sort of the constructor. And then we have another public member function that's called print. The print function is just gonna sort of display the print out the value that's stored in those private data members.